NASA gave key information about Pluto that challenges what we assumed. We realized, what is NASA suggesting here? Are they deducing the most recent disclosures from the New Horizons space test, which shows that unusual things are happening on Pluto's surface? One of the most unsettling pictures shows something that seems to float across Pluto's external layer. This brings up upsetting questions about whether some type of advanced life exists on this distant world or if we are simply observing a unique geographic feature. Pluto might be more than we ever imagined, and the tales it holds are vast and filled with surprises. When Pluto's planetary status was revoked in 2006, researchers knew nothing about the data coming from the New Horizons test, which had just arrived following years of travel. Since then, we have realized that there is much more to this small object than we previously understood. How did dispersed experts come to deny this planet, which we had grown up with? The justification for its renaming had to do with the discovery of other small planets in the Kuiper belt. They considered that a more defined boundary was needed to distinguish a planet, a dwarf planet, or a trans-Neptunian object. Despite its size and round shape, Pluto shares its orbit with several other objects. Its orbit is thus not considered perfect, which was used as the reasoning for not classifying it alongside the larger planets of the solar system. This decision caused disappointment worldwide. Many people felt it was a shame, and this change stirred protests from prominent scientists and even ordinary citizens, who campaigned for Pluto to be renamed as a planet. The planet status had been with us since the 1930s, and its removal from the planetary lineup was a difficult idea for many to accept. In 2015, when New Horizons sent back the first real images of Pluto, the dwarf planet showed us its enchanting face for the first time. These images were the first incredible photos, unlike the artistic renderings we'd seen before. Pluto defied even the sharpest pictures taken by the Hubble Space Telescope, offering a clearer view of its surface. What New Horizons revealed was staggering. Pluto appeared far more dynamic, diverse, and rich than we had ever imagined. The planet, on the outer edge of our solar system, gained many new fans. Perhaps one day, scientists will reconsider Pluto's classification and bring it back into the planetary lineup. The first confirmed pictures of Pluto amazed the world. It was a revered moment when the first data from the New Horizons test arrived at mission headquarters in 2015. Everyone present knew they were about to see a planet they always recognized but had never seen up close. The images were pieced together from massive amounts of individual data collected by the test. What the test revealed about Pluto was a discovery that turned our understanding of this distant planet on its head. Pluto was found to be remarkably different, more varied, more organized, and more alive than planetary experts had initially thought. The test revealed fascinating features on Pluto, showing a world that seemed full of existence. With ice mountains, deep rifts, and smooth cold surfaces, the planet appeared far more dynamic than anyone had expected. Since 2015, each new discovery has been a source of awe, offering a clearer picture of Pluto as a place full of geological wonders and surprises. Walking on Pluto's surface seemed almost surreal. When a moving image streamed in the media in 2016, it appeared as if a person was walking across a honeycomb-shaped snowfield. These icy land structures, unlike those on Earth, were not made of water but of nitrogen and methane. Researchers recognized the feature as a massive block of ice floating on the surface, made of solid nitrogen. The landform suggested that there was a supply of nitrogen several kilometers deep underground, where geological forces pushed the solid blocks up, creating the unique honeycomb shapes. This finding indicates that Pluto may have a warm internal core, which could suggest that pockets of liquid exist beneath its surface in the form of oceans or magma. The New Horizons team, led by William McKinnon, compared Pluto's internal features to the Hudson Bay in Canada. Computer simulations suggested that the terrain we see today has been shaped over millennia by geological cycles. One particularly interesting aspect of Pluto is the large, striking X-shaped feature, which was likely formed by sublimation, a process where a substance transitions directly from a solid to a gas without going through a liquid state. Pluto's unique weather conditions were also revealed through New Horizons findings. Pluto has a thin atmosphere made of nitrogen, methane, and carbon monoxide, which changes significantly depending on how close or far Pluto is from the Sun. The changes in Pluto's atmosphere not only affect the weather but also its surface conditions. One of the most exciting discoveries was the snow on Pluto, made of frozen nitrogen and methane. Unlike Earth, where snow is made of water, Pluto's snow is formed from these more volatile gases. These gases accumulate and fall as snow, creating new layers of ice that continuously reshape the surface, driving other geological developments, including glacial movement and potentially cryovolcanic cycles. These environmental cycles on Pluto are linked to changes in atmospheric pressure. When Pluto is closest to the Sun, the small amount of heat it receives causes its atmosphere to expand and rise. As Pluto moves farther away, the atmosphere freezes and sinks, leading to nitrogen and methane snowfalls. These cycles highlight a dynamic, ever-changing surface, more alive than previously thought. Curiously, Pluto's famous heart-shaped region, known as Sputnik Planitia, has also been a subject of great interest. This massive heart-shaped ice region spans about 1,000 kilometers and consists mainly of nitrogen ice, with traces of frozen methane and carbon monoxide. The surface of Sputnik Planitia contrasts sharply with the darker regions around it. Geologically, Sputnik Planitia is thought to be an impact structure later modified by volcanic processes. However, Pluto's volcanism differs from that on Earth. Pluto experiences cryovolcanism, where cold materials rise from its interior and freeze on the surface. The ice sheets of Sputnik Planitia are believed to be continuously renewed by internal processes, suggesting the presence of liquid water beneath the ice, kept liquid by heat from Pluto's core. Researchers are intrigued by the possibility that life could exist in this subglacial ocean, though it is still not fully understood. Another fascinating feature of Pluto is its moon, Charon. Before the New Horizons mission, Pluto's moon was not well understood. Discovered in 1978, Charon is incredibly large compared to Pluto, with a diameter about half that of Pluto itself. The two bodies are tidally locked, meaning they always show the same face to one another. Charon's surface is dramatically different from Pluto's, with large cliffs and vast impact basins. Scientists believe Pluto and Charon may have exchanged materials over time, much like how comets interact. Pluto, once considered the 10th planet in our solar system, has long captured the imagination of astronomers, scientists, and the general public. Discovered in 1930 by Clyde Tombaugh, it remained an icon of planetary exploration. However, in 2006, the International Astronomical Union reclassified Pluto as a dwarf planet, sparking controversy and debate. Despite this reclassification, Pluto continues to captivate scientists and enthusiasts alike, who remain eager to study this distant and mysterious world on the edge of our solar system. Since the New Horizons probe made its flyby of Pluto in 2015, excitement surrounding this faraway world has only grown. The mission revealed not only unexpected variations in Pluto's surface features, but also hinted at the possibility of dynamic geological processes. This has led to significant shifts in scientists' perspectives on planets, dwarf planets, and the potential for life in the outer reaches of the solar system. Many once considered Pluto a cold, dead rock, but the data now suggests it may be far more unique and intriguing than anyone had expected. One of the key discoveries from the New Horizons mission is that Pluto's surface is not static, as one might expect from an object so far from the Sun. Rather, evidence points to dynamic cycles shaping the landscape. The presence of vast ice fields, valleys, and mountains suggests that some areas on Pluto are constantly being reshaped by forces from beneath the surface. These findings challenge our assumptions about how planets and moons behave in the farthest reaches of the solar system. For example, the nitrogen ice plains of Sputnik Planitia, which form part of Pluto's heart-shaped region, are believed to undergo periodic renewal. This phenomenon is thought to be driven by cryovolcanism, where the planet's internal heat causes materials like nitrogen, methane, and water to rise through the ice, only to freeze on the surface again. This ongoing cycle gives Pluto's surface a constantly changing appearance, with new ice continuously forming, creating intriguing landscapes that evolve over time. Furthermore, the fact that these icy plains are relatively smooth, with very few craters, suggests that the surface has been resurfaced relatively recently. The low number of impact craters points to geological activity, a rare feature in the outer solar system. The hypothesis that Pluto may have a warm interior, with pockets of liquid nitrogen or methane, further supports the idea of a planet far from being dormant. These discoveries suggest the presence of a subsurface ocean, which could potentially harbor life, an enticing prospect for researchers focused on astrobiology. The remarkable nature of Pluto's atmosphere also contributes to the mystery. It is a thin envelope made up of nitrogen, methane, and carbon monoxide, and it changes dramatically depending on Pluto's distance from the Sun. These atmospheric changes not only influence Pluto's weather but also its surface conditions, creating a complex and dynamic environment. The phenomenon of nitrogen and methane snowfalls, along with the potential for cryovolcanic activity, adds further depth to our understanding of Pluto's geological processes. In conclusion, the New Horizons mission has transformed our view of Pluto from a cold, distant object on the fringe of the solar system to a fascinating, active world full of surprises. As more discoveries are made, it becomes increasingly clear that Pluto is a place of incredible complexity, with a rich history and potentially even the conditions necessary to support life. Scientists now see Pluto as a dynamic, evolving world, challenging our previous notions of what planets, and dwarf planets, can be. As we continue to explore this mysterious world, it is likely that new revelations will continue to shape our understanding of the outer solar system and beyond. As our understanding of Pluto continues to evolve, so does the fascination with its potential for harboring life. The possibility of a subsurface ocean, kept warm by the planet's internal heat, raises exciting questions about the conditions that could support life beyond Earth. While the exact nature of this potential ocean remains a topic of investigation, the discovery of its existence, or at least its likelihood, adds a thrilling dimension to the ongoing study of distant worlds. Scientists are now pondering whether life could thrive in the icy depths of Pluto's oceans, in environments far removed from the sun's warmth. The scientific community is also deeply invested in understanding the processes that allow Pluto's surface to remain so dynamic. The recent findings suggest that the planet has experienced, or is still experiencing, internal heat that drives geological processes, including the possibility of cryovolcanism, an ice-based form of volcanism. This stands in stark contrast to our earlier assumptions of Pluto as a lifeless, frozen rock. One of the most compelling aspects of Pluto is how its active, ever-changing surface challenges traditional models of planetary geology. Pluto's orbit around the Sun is highly elliptical, which results in fluctuating environmental conditions, including the freezing and thawing of its atmosphere and surface. These extreme changes play a key role in shaping the landscape, driving both erosion and new formations. The interaction between Pluto's atmosphere, its surface, and its interior might create a sort of cyclical, self-regulating system. As the planet moves closer to the Sun, its thin atmosphere expands and becomes more volatile, potentially influencing surface features like the nitrogen ice plains of Sputnik Planitia. As Pluto moves farther from the Sun, the atmosphere contracts and freezes, leading to further geological activity. This continuous dance between the interior, surface, and atmosphere keeps Pluto in a constant state of flux, ensuring that its geological features evolve over time. Moreover, the discovery of cryovolcanic features on Pluto adds another layer of complexity. While Earth's volcanoes are fueled by molten rock, Pluto's volcanoes may erupt with icy materials like water, nitrogen, and methane, creating vast ice fields and reshaping the landscape. This behavior suggests that Pluto may not be as frozen and static as previously thought. Instead, it could be a planet in a state of constant transformation, much like Earth, but on a different scale and in a more extreme environment. The exploration of Pluto has opened new doors for understanding not only this distant dwarf planet, but also the broader processes that shape planetary bodies throughout the solar system. Pluto's unique combination of a thin atmosphere, dynamic surface features, and potential subsurface ocean has made it a focal point in the study of planetary science. It serves as a reminder that even in the most remote corners of our solar system, there are worlds full of mysteries waiting to be unraveled. With the success of the New Horizons